1, that is UV formula వస్తుంది. Okay, if n equal to 2, UV formula one వస్తుంది ఏంటి, again go for the one more time differentiation. Like that we have to take the proof by n equal to 1 it is true and n equal to k assume that is true, and with the help of these two cases we have to prove that it is true for n equal to k plus 1 also. So by mathematical induction method finally we can conclude that it is true for all values of n, that is uv whole to the power of n equal to nc0 formula వచ్చింది, uv whole to the power of n equal to nc0 x to the power of u to the power of n v plus nc1 v to the power of n minus 1 v dash, v to the power of n u to the power of n minus 1 means what is the meaning of that one? We are going to take u n minus 1 times of differentiation. Okay, and v dash means one time differentiation plus next third term ఏమొస్తుంది, what about third term? nc2 u to the power of n minus 2 v to the power of 2. So u to the power of n minus 2 means we are going to take partial difference, we are going to take the differentiation of u n minus 2 times. Okay, like that. Last what is rth term? ncr u to the power of n minus r v to the power of r plus and so on. What about last term? ncn u power 1 into u into v to the power of n, right? That is the complete proof of Leibniz theorem. Based on that Leibniz theorem, I explained certain problems also. Okay, one or problems system, similar example, just replace n equal to nc0 value, nc1 value, nc2 value. Okay, so that we will get the complete by taking complete simplification we will get the nth derivative. వీటిని బేస్ చేసుకొని with the help of this I can start the next topic here. I will share the screen. Yes. 1 minute. Yes. Yes, is it screen is visible?
Yes, sir.
Right.
Yes, sir.
Here. Okay. This is continuation topic to previous class. So we should this proof and we did this problem also. So finally we got this is the answer. After taking the complete simplification, we'll get the remaining also similar examples. So next I will move the next topic, that is, so these are some practice problems. Okay. Yes. Next unit 5, partial differentiation and Euler's theorem. Yes, this is also one of the most important topic, Euler's theorem. Partial differentiation and Euler's theorem on homogeneous functions. Okay. So first, coming to the before starting that, okay, I will explain the one small topic, that is wait. Of course, all these are okay. Except problems, topics. Yes, no topics. Okay, let us start this. So partial differentiation and Euler's theorem on homogeneous functions. Okay. So in this chapter, Euler's theorem is most important. So in our final exam, they will ask the questions from theorem as well as problematic part on Euler's theorem also. Okay. So you have to go through the theorem statement as well as proof and its related problematic part also. Okay. See here. First, functions of two variables. Functions of two variables, and in previous units there we discussed functions on single variable, that is y equal to f of x, means y is the dependent variable and x is the independent variable. So that there I have taken dy by dx, that is ordinary differentiation. But whenever the independent variables are, yes, listen carefully, whenever yes the independent variables are more than one. That is, dependent variable is only one, but independent variables are more than one, whether it may be one or more. Then that kind of derivatives are known as partial derivatives center. So a derivative which consists only one dependent variable, but independent variable should be either one or more. Then that derivative is known as partial derivative untuna. So for example, let us suppose z equal to f of xy. Z equal to f of xy means here z is a dependent variable on two independent variables x and y. So z is depends on two independent variables x and y. So in this case, I can get the partial derivatives because independent variables are more than one. Sometimes I'm going to take the differentiation with respect to x. Another time I'm going to take the differentiation with respect to y. So we'll get the notations. If we take differentiation with respect to y, z equal to f of z equal to f of x. So if we take the differentiation with respect to x, we'll get dou z by dou x. Similarly, if we take differentiation with respect to y, we'll get the dou z by dou y. So whenever we are going to take the partial differentiation with respect to x, treat remaining all variables are constant, including y and remaining all variables. So whenever we are going to take partial derivative with respect to x, so partial differentiation with respect to x, we have to treat x is the only one variable, remaining all are constants. So while going to take differentiation with respect to x, y will become constant. So y differentiation will goes to 0. Similarly, if we take partial differentiation with respect to y, in this case, treat x is the constant and treat y is the only variable. So I will show it here. I will share the screen. Yes, here. Yes, definition of this. Okay, of course, these are the basic definitions. Okay, yes, here. The function will be z equal to s here here. Yes, the function z equal to f of x represents a surface and it's an equation of the surface. Okay, this is the this equation consists here. Z equal to f of x consists. Z is a dependent in terms of two independent variables where x and y are independent variables. So whenever the variables are independent variables are more than one is there, again I want to discuss how to apply the limits definition, how to apply the continuity definition on multi-variables, that is on two variables. Here in a previous unit, yes, in previous unit, there we discussed limits definition and continuity definition. Suppose if it is single variable is there, then how we are going to define the definition? Limit as extends to a f of x equal to L. That is, x is approaching to a f of x can be tends to L. Then L is called limit point of f of x at x equal to n. That is on single variable. If you come to the same definition, two variables. That is, f is a function of two variables x and y. So then we are going to take the limit as x tends to and y tends to. At a time you have to take the two limits quantities. So limit x comma y tends to suppose 0 0 0 limit that is different gesture. Limit x comma y tends to 0 0 f of x comma y equal to L. That is the combination of both function f of x y tends to L. Then L is called limit point of the function f of x comma y. Okay, I will show it here. So it is here. Yes, neighborhood point. Okay, this is okay. Yes, limit these definitions here. So let z equal to f of xy. Yes, z equal to f of xy. F of xy is such that d to r f of xy is mapping from d to r be a real valued function of two variables defined on a domain D contained R cross to R, and let a comma be the any point in D, then we say that the limit L then we can say that L is the limit point of this function f of xy as x comma y tends to a comma b. That is, x is approaching to a than 0, there exists a number delta greater than 0 is such that for every point x comma y belongs to D must be satisfying the condition 0 less than x minus a whole square plus y minus b whole square less than equal to delta. Then we have mod of f of x minus L less than epsilon, and it is denoted by limit x comma y tends to a comma b f of xy equal to L. It means as x comma y is approaching to a comma b, f of xy will be tends to L. So either definition in previous unit we discussed for single variable like this, mod of f of x minus y less than epsilon. Instead of this, there I have written mod of f of x minus L less than epsilon. Am I right? Mod of f of x minus L less than epsilon ఉంటే f of x కు L లిమిట్ పాయింట్ అన్న. ఇప్పుడు మల్టీ వేరియబుల్స్, టూ వేరియబుల్స్, దట్స్ వై I am taking mod of f of xy minus L less than epsilon. Similarly, coming to the notations also, in the previous unit, that is at the beginning, first unit, there I have taken limit definition on single variable. Limit as x tends to a f of x equal to L. Then we are saying L is the limit point of f of x at x equal to a. That is the definition for single variable. But if it is two variables, we are going to take yes. So let us take limit as x comma y tends to a comma b, f of x comma y equal to L. So it means, yes, don't make nice. It means x tends x comma y tends to a comma b, then f of x y tends to L. So then we can say మాట్లాడదమ్మా. హలో హలో, ఎందుకు మాట్లాడుతున్నారు? హలో, మాట్లాడకండి అమ్మా, స్పీకర్ ఆఫ్ చేసుకోండి.
సార్ యు మ్యూట్ ఆల్ స్టూడెంట్స్ సార్.
ఓకే ఓకే, నేను మ్యూట్ చేస్తానండి. Yes, I will going to mute all. First, let them complete this definition. Then I will discuss the problematic part. Okay. See here. So, in two variables, the limit function will be defined like this. That is, for given epsilon greater than 0, there exists a real number delta greater than 0 is such that for every point x comma y belongs to D, satisfying 0 less than x minus a whole square plus y minus b whole square less than delta square, we have mod of f of x minus L less than epsilon. So that is in terms of notation, limit x comma y tends to a comma b of function f of x y equal to L. Then L is called limit point of function f of x comma y at where at x comma y tends to a comma b, means at x tends to a, y tends to b. Okay. Now coming to the conditions, is coming to the remotes, is the limit point f of x y at a comma b may or may not exist. If it is exist, then it should be unique. So if the limit point is exist for a function f of xy, then that must be unique. It means we cannot get the different limit points. If the limit point is exist, means that should be one and only one, that should be unique. Next, second point, the limit point of the function f of xy at a comma b exist when the function has same limit along the path, say x tends to a, y tends to b, or y tends to b, or x tends to a. It means here we are having two variables x and y. So for the given function f of xy, if you substitute first x tends to a or second y tends to b, or else if you substitute first y tends to b, second x tends to y, the answer should be indicate same. If you x tends to a first, y tends to be second, suppose the answer is 0, let us assume. Next case, if you apply first y tends to be, next second time x tends to a, in that case if answer is also same, then we can say for that kind of model problems limit point is existing. If both are different, then we can say simply limit is not existing. Okay, that is the meaning of this second point. I will read once again here. The limit of the function f of xy at a comma b exists when the function has same limit along the path, say x tends to a, y tends to b, or y tends to b, x tends to a, etc. in the xy plane. And the limit does not exist means if it is not a finite value. So what is the meaning of this? If limit x tends to a, x comma y tends to a comma b, f of x y equal to L. If this L is finite, then we are saying it having limit point. Suppose if L is infinitive, whether it may be plus infinity or minus infinity, then we can say for that kind of problem, limit does not exist. So if it is infinite, the limit does not exist. Next, third point, fourth point. If the limit is the path depends on which the point xy approaches a comma b, then the limit does not exist. For discussing this fourth point, I will explain the one examples here. Yes, evaluate limit x comma y tends to 0, 0, x square plus y square. Okay, x square plus y square. So first let us take limit x tends to 0, y tends to 0 of the function x square plus y square. So see this limit x tends to 0, y tends to 0. First I am writing x tends to 0, next I am writing y tends to 0 means first we have to apply the limit for y variable. Then afterwards finally apply the limit for x. Okay, see here. I will show it. Limit x tends to 0, y tends to 0, x square plus y square means limit x tends to 0 into limit y tends to 0 of x square plus y square. So ఇట్లా ఉండదు దీని మీనింగ్ ఏంటి ఫస్ట్ y లిమిట్ అప్లై చేయండి నెక్స్ట్ గో ఫర్ ద x లిమిట్ సో see here limit x tends to 0 y tends to 0 of x square plus y square equal to limit x tends to 0 limit y tends to 0 x square plus y square. If you put y equal to 0 then it will become x square plus 0 square means we will get the only x square. So for remaining function go for the next last limit x tends to 0 x square. So if you put x equal to 0 again it indicates 0 square means 0 only. So next if we interchange the x to y, y to x, that is limit previously it was x tends to 0, y tends to 0. Now I am going to take limit y tends to 0 first, next x tends to 0. So limit y tends to 0, x tends to 0 means first take limit x tends to 0 first. Then for getting that final result, last apply the y tends to 0. So limit y tends to 0, x tends to 0, x square plus y square means limit y tends to 0, limit x tends to 0, x square plus y square. So now if you put x equal to 0, it shows 0 square plus y square. So limit y tends to 0, y square. So if you put y equal to 0, so again it is 0 square means 0. So we are getting after interchanging the path direction x to 0, y to 0 or y to 0, x to 0, the result is showing same. So if it is like this, then we can say the given point having or the given function having limit point. Therefore the given function having limit point, it means the given function having the limit point at 0, 0. Okay, is it clear, Arvind? Let's say so if we change the path, if we take y equal to mx, y equal to mx, okay, if it is y equal to mx, then we are saying what about this? If y equal to mx means we can show we'll get the value in the place of y equal to mx square, limit again x tends to 0, y equal to mx square, x square plus y square, limit x tends to 0, limit y equal to mx square. So in the place of yes, y put mx. So limit x tends to 0, limit y tends to mx, x square plus y square. So limit x tends to 0, x square plus m square x square. So m square x square means here x square is common, put x square common, x square into y 1 plus m square. Again last put x equal to 0. So 0 square into 1 plus m square means finally again we'll get the 0 only. So along the path again it is y equal to mx square. Okay, na? Next, see here, limit x tends to 0 and y equal to mx square, x square plus y square limit x tends to 0. Yes. So if you change the path again the result is 0 is showing. Similarly if you change the path from previously I have taken the path is y equal to mx straight line path. Now if you take the path y equal to mx square, y equal to mx square, then y equal to mx square, it indicates what it is, parabolic form. Okay, second degree polynomial. So I'm changing the path from straight line to parabolic. Then again we'll get the same answers here. Check out y equal to limit x tends to 0, y equal to mx square, x square plus y square equal to limit x tends to 0, limit y equal to mx square, x square plus y square equal to. So in the place of y put mx square. So limit x tends to 0, x square plus m square x to the power of 4, because x square y m x square means m square x to the power of 4. So again here x square is common, If you take x square common, limit x tends to 0, x square into 1 plus x square m square. Here x square is not printed, it is x square into m square. So again, if you put x equal to 0, 0 into something, total it is 0. So if the path is changing, so that is thus one can see that epsilon delta definitions, that the value of limit along the path is same and the value is also finite. Every time it is showing 0. Therefore, for this function limit is existing. Okay. Similarly, see one more example. Show that limit x comma y tends to 0 0 x minus y by 2x plus y does not exist. So I want to show that if you change the directions, the path directions, one time it will show the answer and another time it will show the another answer. If it is different answers are there, then we can say the limit does not exist for this model problem. Okay, let's discuss. Chudandi. Limit x tends to 0, y tends to 0, x minus y by 2x plus y. So limit x tends to 0, y tends to 0, x minus y by 2x plus y. So if you put first y tends to 0, means we'll get x minus 0 by 2x plus 0. So x by 2x, x cancel, we'll get the only 1 by 2. So it is a constant function. So limit x tends to 0, 1 by 2 means there is no any x multiples. So we'll get 1 by 2 answer. Next, if you change the path, that is limit first y tends to, next x tends to. So limit x minus y by 2x plus y equal to limit y tends to 0, limit x tends to 0, x minus y by 2x plus y. So if you put x equal to 0, 0 minus y by 2 into 0 plus y minus y by y. So y cancel, minus 1 will get minus 1. So limit y tends to 0, minus 1, which is equal to minus 1. Because it is a constant function, there is no y multiples, we'll get the minus 1. So in both cases it is finite value, but we are getting different values. For this function, limit point is not existing. That the repeated limits exist and are not equal, therefore limit does not exist. Similarly, go through the remaining examples. Next, continuity. Coming to the continuity function definition. Okay. Yes. Similarly, the continuity function definition is yes. What is the continuity function definition in single variable? Continuity function definition in single variable, what it will shows as same definition if you apply on two variables. That is, if it is the continuity function, f of x is limit x tends to a, f of x equal to f of a. That is, as x tends to a, f of x can be tends to f of a. Then we can say f is satisfying the continuity property. So f is a continuous function at x equal to a. Similarly, same definition coming to the two variables. So limit x comma y tends to a comma b of f of x y equal to f of a b. Then we can say f of x y is a continuous function at x comma y equal to a comma b. Okay, I will show it here. Yes. Yes, I will share the screen. See here. A function z equal to f of x is said to be continuous at a point a comma b belongs to d contained r cross r if f of x y is defined at a comma b and limit x comma y tends to a comma b, f of x y is exist and limit x comma y to a comma b, f of x y equal to f of a b. Then we can say f of x y is the continuous function at a comma b. Okay, and based on this we have different problems. Okay, just go through these problems because these are similar examples. I will move the next topic, that is partial derivatives of first order and higher orders. Okay, partial orders. Okay, this is here z equal to f of x by be a function where z is a dependent variable and x and y are two independent variables. Then differentiation. Yes, I finished limits definition on two variables, continuity definition on two variables. Similarly, differentiable definition on two variables. What is differentiable definition on single variable? Limit h tends to 0, f of x plus h minus f of x by h. exist, then we can say f of x is a differentiable at 0. Similarly, that is definition on single variable. Same definition if you apply on two variables. So limit x tends to 0 f of x plus h. So combination of x y is there, but I am taking at x at dou z by dou x means just replace wherever x is there in the place of x plus h. So limit x tends to 0 f of x plus h comma y minus f of x y by h. If it is exist and it is divided by dou z by dou x. Okay, this is partial differentiation with respect to x. Similarly, if you take partial differentiation with respect to y, that is limit k tends to, as previously I have taken h, then now you can take k. So limit k tends to 0 f of x comma y plus k minus f of x comma y by k. That is, in the place of y I am taking y plus k. So limit k tends to 0 f of x comma y plus k minus f of x comma y by k is exist, then we can say it is a partial differentiation with respect to y. That is, it is denoted by dou z by dou y. Similarly, second differentiation is also same second derivatives. Yes, I will explain the one examples here. Okay. Yes. Next one more. If z is a function of uv, where u is a function of again xy and v is a function of phi of xy, then for that kind of model problem, the derivation will be given by dou z by dou x is dou by dou x of u by v. So ఇక్కడ ఏంటి apply the u by v formula. Of course, these are common derivatives. Okay, just go through it, and with respect to partial differentiation, as this is answer. With respect to x అన్నప్పుడు dou u by dou uv formula, use uv formula and u by v formula apply the same. And of course, these are the examples. So let's come to this example. Yes, I will explain this here. I will do this problem. So what is question? Z equal to log of x square plus y square. Okay. For this question is asking find all first order derivatives. Okay. Yes, I will do these problems here. Yes. See here. Screen కనబడుతుందా? Yes, is it visible? Yes, here. So z equal to log of x square plus y square. So I want, for this I want to find dou z by dou x. So differentiate above equation with respect to x partially. So dou z by dou x will become log x differentiation 1 by x, but in the place of x we are here we have 1 by x square plus y square means it is x square plus y square. Log x differentiation 1 by x, but in the place of x here we have 1 by x square plus y square. So log x means 1 by x means 1 by x square plus y square. For internal function with respect to x, so partial differentiation with respect to x means x square differentiation to x, but y square differentiation 0. Why? Because whenever we are going to take partial differentiation with respect to x, treat remaining all variables are constant. So here y is a constant. So this is answer. So got 2x by x square plus y square. This is dou z by dou x. Similarly, coming to same this equation, z equal to log of x square plus y square. So differentiate with respect to y partially. Differentiate this equation with respect to y partially. Then we will get, yes, we'll get this is here. What about this? We'll get so this is dou z by dou y equal to again log x 1 by x square plus y square. Okay, so 1 by x square plus y square, but differentiation with respect to y means x is constant in this case, x differentiation 0, y square differentiation 2y. So this is 2y by x square plus y square, dou z by dou y. So these are the first order derivatives. Similarly, I want to find second order derivatives, means dou square z by dou x square. So what about dou z by dou x here? Yes, Let's see here. Dou z by dou x is 2x by x square plus y square. So if we take this equation, one more time differentiation with respect to x, differentiate with respect to x partially. So see here. So it will become dou by dou x of dou z by dou x equal to dou by dou x of 2x by x square plus y square. So this will become dou square z by dou x square, and this is dou by dou x 2x by x square plus y square. So here x multiples are present in numerator and well denominator. So this is q and this is v. So apply the uv formula. What is uv formula? Uv whole dash. This is v u dash minus v dash u by v square. So here u is 2x, v is x square plus y square. So this is v square means x square plus y square whole square, and x square plus y square into differentiation of u 2x 2. This is 2. Okay. Next minus 2x into u into differentiation of v square differentiation, that is x square plus y square differentiation 2x, for x square it is 2x, for y square it is 0. So this is answer. So what about this total quantity? If you multiply with 2, 2x square plus 2y square minus 2 into 2, 4x square divided by x square plus y square whole square. So this is 2y square, 4x square minus 4 square plus y square means minus 2x square by x square plus y square whole square. This is second order derivation with respect to x. Similarly, if you come to the same, this I got dou z by dou y is 2y by x square plus y square. Dou z by dou y is, what about this, 2y by x square plus y square. Okay. So for this equation, if we take partial differentiation with respect to x, take partial differentiation with respect to x, we'll get uh, differentiate with respect to y partially, so that we'll get the second order derivative with respect to y. It is dou by dou y of dou z by dou y equal to dou by dou y of 2y by x square plus y square. So this is dou square z by dou y square, and this is, yes, again here y multiples are present in numerator and denominator. Again apply the u by v formula. So x square plus y square whole square, x square plus y square into u differentiation 2 minus 2y into x square differentiation, because with respect to y means y x is a constant. So this is constant plus 2y. So this is 2x square plus 2y square minus 4y square by x square plus y square whole square. Okay. So this is 2x square, 2y square minus 4y square means minus 2y square divided by x square plus y square. So these are second order derivatives. Okay. Is it clear? Next here, and one more. Yes. If it is dou z by dou y, dou z by dou y is 2y by x square plus y square. Yes, just now I got it is. So for this equation, I want to take differentiation with respect to x. So first time I have taken differentiation with respect to y. For this equation, I am going to take differentiation with respect to y. That is differentiate with respect to x. So it will become dou by dou x into dou z by dou y. And first y to chesna, next x to chestunna. So it will become dou by dou x of 2y by x square plus y square. Okay. This is dou z by dou y value. So for this equation, if we take partial differentiation with respect to x, it will become denominator only. So no need to take u by v formula. So just I'm writing this is 2y outside of differentiation dou by dou x, and bring this 1 by x square to numerator, x square plus y square to the power of minus 1 into dx. So this is 2y, yes, n into x to the power of n minus 1, minus 1 into x square plus y square all to the power of minus 1 for internal function 2x plus 0, because differentiation with respect to x. So this is 2x plus y square is 0. So what is final answer? 2x into 2y with minus symbol, minus 4xy. I'm bringing this into denominator, x square plus y square whole to the power of 2. This is dou square z by dou x dou y. Okay. Similarly, if we take dou z by dou x, what about dou z by dou x value? Yes, dou z by dou x is this here. Dou z by dou x is, yes, yeah, I did already. It is 2x by x square plus y square. Okay. For this quantity, I'm going to take partial differentiation with respect to y. Previously, first I have taken differentiation with y, then I am taken differentiation with respect to x, so that I got dou square z by dou x dou y. Now again, first I am taking with respect to x. For this equation, differentiate with respect to y partially. So we'll get, it is dou by dou y of dou z by dou x equal to dou by dou y of 2x by x square plus y square. Again, it will become dou square z by dou y dou x. And here in y multiples are present in denominator only. So here 2x is constant. So 2x is constant means dou by dou y of, bring this quantity to numerator x square plus y square whole to the power of minus 1. For this, we have to apply the n into x to the power of n minus 1 formula. 2x into minus 1 into x square plus y square whole to the power of minus 1 minus 1. Okay, n into x to the power of n minus 1. And for internal function with respect to y, means that x is a constant. So x is 0, y square differentiation 2y. So what is final answer? Minus 2x into 2 into minus 4xy divided by x square plus y square whole square. So this is dou square z by dou y dou x. Okay. So for every problem, not only this example, these two derivatives are always same here. Dou square z by dou x dou y is minus 4xy by x square plus y square. Similarly, dou square z by dou y dou x is again same, it is minus 4xy by x square plus y square. So these are the second order derivatives. Okay, just go through this. I will share all these papers after completing the class. Yes, next. Yes, are you following me? Is it understood? Second order derivatives. How we are going to take the partial derivatives? అర్థమవుతుంది కదా?
Yes, sir.
Next, based on this, based on this, I will going to explain the one of the most important theorem, that is Euler's theorem on partial derivatives. Okay, so this is the, yes, tell me.
Sir, in part 21 by example,
Yes,
y equals to mx path మీరు తీసుకున్నారు కదా,
అవును.
అది ఎందుకు తీసుకోవాలి సార్ అలాంగ్
అంటే
పాత్
పాత్ చేంజ్ చేసిన, పాత్
ఇక్కడ
చేంజ్ చేసిన,
లిమిట్స్ ఈక్వల్ అని వచ్చినాయి కదా సార్.
yes. So of course we got limits change, but if we change the path, the limits value does not change. For showing
why-
that result, I have taken that one.
y equals to mx ఎందుకు తీసుకోవాలి?
You can take any one. Y equal to mx indicates straight line. Y equal to mx square indicates a parabola equation. Just I am saying the straight line format and parabola format. In both cases, you can take not only that, you can take any one and just check out the result. Limit will goes to same quantity. Okay.
సరే, లిమిట్స్ రెండు ఈక్వల్ వస్తేనే కాదు, ఈ పార్ట్స్ కూడా ఈక్వల్ వస్తే
అది కాదు
ఇది ఎగ్జిస్ట్ అవుతుంది అన్నట.
లిమిట్స్ రెండు x tends to y, y tends to వాల్యూ ఎంత వచ్చిందో y tends to and x tends to సేమ్ వస్తే లిమిట్ ఎగ్జిస్ట్ అన్నట్టు. అటువంటి దానికి పాత్ ఎగ్జిస్ట్ అవుతుంది. అటువంటి ప్రాబ్లమ్స్ కి పాత్ ఎగ్జిస్ట్ అవుతుంది. ఓకేనా?
ఓకే సార్, ఇక్కడ ఓన్లీ ఎవాల్యుయేట్ అని ఇచ్చారు కదా సార్, మరి అలాంగ్ ద పాత్ ని
అంటే అది క్లారిఫికేషన్, అది మీరు ఎగ్జామ్ లో చేయనవసరం లేదు. క్లారిఫికేషన్ కోసం మీకు ఎక్స్ప్లెయిన్ చేసిన నేను. ఓకే
ఓకే సార్.
రైట్. Yes, do you have any doubts? Otherwise, I will go to the next topic, Euler's theorem. Okay? ఇది ఒకటి చెప్పి స్టాప్ చేస్తాను చూడండి. దిస్ ఇస్ ద ఇంపార్టెంట్ టాపిక్ ఫర్ యువర్ ఫైనల్ ఎగ్జామ్ పర్పస్. థియరమ్ ఇంపార్టెంట్ అండ్ ఇట్స్ థియరమ్, ఇట్స్ ప్రూఫ్ as well as its related problems important. Okay, let me start the first theorem and its proof. Okay, yes, Euler's theorem. Right. Yes, Euler's theorem statement చూడండి ఏముంటుందంటే, on homogeneous equations. What is the meaning of homogeneous equation? In entire equation, each and every individual terms having the equal degrees. And suppose x power n అనుకోండి, remaining all also consisting same degrees. And on homogeneous equations, the Euler's statement will be like this: if z equal to x to the power of n f of y by x, then x dou z by dou x plus y dou z by dou y equal to nz. If it consists nth degree. Okay, I will show it here. మీరు మాట్లాడకండి, జస్ట్ చూడండి, నేను కంప్లీట్ మీకు ప్రూఫ్ చేసి చూపిస్తా. Yes, I will share the screen. Yes, this is second order, already we finished. Okay, check చేసుకోండి.
సార్ పార్షియల్ డిఫరెన్స్ కి నార్మల్ డిఫరెన్షియేషన్ కి డిఫరెన్స్ ఏంటి సార్?
అదే చెప్తున్నామ్మా. ఆర్డినరీ డెరివేటివ్ చూడండి, ఆర్డినరీ డిఫరెన్సియేషన్ పార్షియల్ డిఫరెన్సియేషన్ కి తేడా ఏంటంటే, ఇన్ ఆర్డినరీ డిఫరెన్సియేషన్ ఇట్ కన్సిస్ట్ ఓన్లీ వన్ డిపెండెంట్, ఓన్లీ వన్ ఇండిపెండెంట్ వేరియబుల్. ఓకే, అంటే ఎంటైర్ ఈక్వేషన్ కన్సిస్ట్ ఓన్లీ వన్ డిపెండెంట్ వేరియబుల్, ఓన్లీ వన్ ఇండిపెండెంట్ వేరియబుల్. సపోజ్ ఇఫ్ ఇట్ ఇస్ dy by dx ఉంది అనుకోండి అమ్మా, dy by dx ఉంది. What is y, what is x here? dy by dx. In numerator I have taken y, in denominator x తీసుకున్నా. dy by dx అంటే y is the dependent variable, in denominator లో x ఉంది, x is the independent variable. So
ఇండిపెండెంట్.
an equation which consists only one dependent, only one independent, then with the help of this, whatever the derivatives we are getting, the derivatives are known as ordinary derivatives. ఓకే, అదే పార్షియల్ డెరివేటివ్ ఉన్నప్పుడు ఏంటి, డిపెండెంట్ వేరియబుల్ ఒకటే ఉండాలి, బట్ ఇండిపెండెంట్ వేరియబుల్ షుడ్ బి ఐదర్ వన్ ఆర్ మోర్ ఉండాలి. ఇంత చెప్పింది అదే కదమ్మా. z ఈక్వల్ టు f ఆఫ్ x y, దేర్ z ఈజ్ ఎ డిపెండెంట్, డిపెండెంట్ ఒకటే ఉంది, బట్ ఇండిపెండెంట్ వేరియబుల్స్ ఒకసారి x తీసుకుంటున్నా, ఒకసారి y తీసుకుంటున్నా. దట్స్ వై ఐఎమ్ టేకింగ్ డిఫరెన్సియేషన్ వన్ టైమ్ విత్ రెస్పెక్ట్ టు x, అనదర్ టైమ్ విత్ రెస్పెక్ట్ టు y. అంటే డో z బై డో x, డో z బై నోటేషన్స్ వచ్చారు d బై కాదు, డో z బై డో y అని రాస్తా. ఒకసారి z x తో డిఫరెన్షియేట్ చేస్తున్నా, ఒకసారి z y తో డిఫరెన్షియేట్ చేస్తున్నా. డో z బై డో x, డో z బై డో y. ఓకే,
ఎన్ని వేరియబుల్స్ ఉంటే అన్ని వేరియబుల్స్ డిఫరెన్షియేట్ చేయాలా సార్?
డిఫరెన్షియేట్ చేయాలి, బట్ డిపెండెంట్ ఒకటే ఉండాలి. ఇండిపెండెంట్ రెండు కాదు, మూడు x y w k ఇట్లా ఏమైనా ఉండుకోవచ్చు. ఓకే, డిఫరెన్షియేషన్ విత్ రెస్పెక్ట్, ఒకసారి x, ఒకసారి విత్ రెస్పెక్ట్ టు y, ఒకసారి విత్ రెస్పెక్ట్ టు q, లైక్ దట్. ఓకే
సార్, ఎన్ని పర్మిట్ అవుతాయి సార్ ఒక ఫంక్షన్ కి ఇండిపెండెంట్ వేరియబుల్?
అట్లా లేదు, అన్లిమిటెడ్, అట్లా ఏం లేదు మీకు. ఎన్న నువ్వు రెండు కాదు, ఒక 20 తీసుకో, ఎన్న తీసుకో, దట్ డిపెండ్స్ ఆన్ ప్రాబ్లం.
ఓకే సార్.
ఓకే, ఓకేనా? ఇంకేమైనా డౌటా? చలో స్టార్ట్. Euler's theorem. Yes, Euler's theorem చెప్తా చూడండి. Yes, I will share the screen. Yes, ఈ థియరం కొద్దిగా కేర్ఫుల్ గా వినండి. దిస్ ఇస్ కంపల్సరీ థియరం ఫర్ యువర్ final exam purpose as well as problematic part also. They will ask the questions here. First, before that, first listen. So all these are partial derivatives. Okay, right? Yes, Euler's theorem on homogeneous function. First, come to the homogeneous function. So consider f of x y equal to a naught x power n plus a1 x to the power of n minus 1 y plus a2 x to the power of n minus 2 y square plus up to a n y power n. In each and every individual, see, highest degree is n is there. A naught x power n. Here x to the power of n minus 1 y power 1, minus 1 plus 1 get cancelled. Again degree is n. Similarly, x to the power of n minus 2 y2, minus 2 plus 2 get cancelled, x power n. Like that, a n y to the power of n. Okay. So this equation having equal degrees. So we can say this is the homogeneous function with degree n. This is the homogeneous function with degree n, and it is denoted by like this. Denote chestunna x power n f of y by x. Means if you take x power n common in each and every terms, remaining function f of y by x anukunta. Endukante x common తీసుకున్నా కదమ్మా, so we will get y by x. So x to the power of n into y by x. So a function f of x y is said to be homogeneous function, means it consists equal degrees. In each and every individual term, it consists equal degrees, and it is, if it is the equation is having nth degree, then it is denoted by like this: x to the power of n into f of y by x. Okay, so this is definition. Now with the help of this definition, now coming to the formula. Yes, here for example, f of x y equal to this. If we take x to the power of 1 by 2 common here, f of x y equal to x plus y by root x plus root y. Yes, in numerator I am taking x common, it will become 1 plus y by x. In denominator I am taking root x common, 1 plus root of y by x. So x by root x means still there will be one more root x. So x to the power 1 by 2, x to the power 1 by remaining function amount y of 1 by y by x. It is a combination of y by x function. So if it is function written like this, then we can say here f of xy is a homogeneous function with degree 1 by 2. Okay, is it clear? Similarly, simply if you take y common also, that is also homogeneous function in terms of degree 1 by 2. So based on this, coming to the yes Euler's theorem, this is important. Yes, theorem statement 2. Yes, yes, don't make noise. Matadadama. Yes, I will prove this entire concept. So z equal to f of xy be a homogeneous function of degree n in x and y. Then we have to show that yes Euler's theorem. Then we have to show that x into dou z by dou x plus y into dou z by dou y equal to nz. This is I want to prove. Whenever z equal to f of xy be the homogeneous function means it having nth degree. Degree కూడా statement is f of z equal to f of x is a homogeneous function of degree n in variable x and y. Then x dou z by dou x plus y dou z by dou y equal to nz. This is statement. And coming to the proof, as in the question is giving since z is a function of the homogeneous function of degree n in x and variable, then it can be expressed as yes. Denote just now. It is expressed as x to the power of n phi of y by x. So I'm going to take z equal to f of x y. Z equal to s. Z equal to x to the power of n f of y by x. I am going to take this. Why? Because it is a homogeneous function with degree n. So we can indicate like this: z equal to x to the power of n f of y by x. Okay, na? Yes, I will share the screen. Yes, is it
Yes,
visible?
sir.
Okay.
Yes,
So
sir.
what is our statement? Z equal to f of xy be the homogeneous function with degree n. Then we have to show that like this: x dou z by dou x plus y dou z by dou z equal to nz. So in the statement itself, we given z is a homogeneous function in variables x and y with degree n. Therefore, it is denoted by like this. Okay. Therefore, z equal to, according to definition, this is a notation. Z equal to x to the power of n f of y by x. Assume this is the equation number 1. Now, for these equation, just I want to take partial differentiation with respect to x, then partial differentiation with respect to y, then multiplied with x and y, add them, automatically will get the nz value. So here first, differentiate with respect to x partially. Okay, so z will become dou z by dou x, and here it is x multiples consist here and here. So apply the UV formula. Okay, what is UV formula? UV whole dash is UV dash plus U dash V. So x power n into first f of y by x differentiation. First for outer function f, it is f dash of y by x. For inner function, for y by x, y is a constant. So for 1 by x, what is 1 by x differentiation? Yes, minus 1 by x square.
1 by
Okay,
x square.
minus 1 by x square. So this is minus 1 by x square. Okay, so x to the power, this is completely v dash, u into v dash. For outer function f, it is f dash y by x. For y by x, y is a constant. For 1 by x minus 1 by x square plus y f into y by x, v into u dash. X to the power of n differentiation, n into x to the power of n minus 1. So let us take complete simplification. So this is x to the power of n by x square. If you bring this x square to numerator, it will become x to the power of n minus 2 with minus and y is there. So y into minus y into x to the power of n minus 2 f dash of y by x plus this is n into x to the power of n minus 1 into f of y by x. So first I am writing this one. Next I will write this one here. So n x to the power of n minus 1 f of y by x minus y into x to the power of n minus 2 f dash of y by x. This is dou z by dou x value. Assume this is equation number 2. Okay. Similarly, for this equation 1, I will going to take partial differentiation with respect to y. So what is z value? that is x to the power of n f of y by x. So differentiate with respect to y partially. So dou z by dou y will become s. Here no need to take UV formula because it consists y multiples in f function only. There is no y multiples here. So here x power n is constant. So apply the differentiation with respect to y for only this function. For outer function it is f dash of y by x. For inner function s 1 by x is constant because partial differentiation with respect to x. So 1 by x constant, y differentiation 1. Therefore dou z by dou y is s x power n by x. If you bring x into numerator, it will become x to the power of n minus 1 f dash of y by x. Assume this is equation number 3. So what do I got? Dou z by dou x value, dou z by dou y value. He is asking x into dou z by x, y into dou z by dou y equal to, I want to prove nz. So for this equation 2, I am multiplying with x. So x into equation 2 plus equation 2 into y. So y into equation 3. Then add these two. So x into dou z by dou x plus y into dou z by dou y. So this is left side value. So what about right side value? For this entire function, I want to multiply with x. So x into n x to the power of n minus 1 f of y by x minus y into x to the power of n minus 2 f dash of y by x. Okay, this is plus y into x to the power of equation 3 n minus 1 f dash of y by
Y by
y minus y by x. So if you multiply with x, n into x to the power of n minus 1 x to the power of 1. So it will become x to the power of n only. Plus 1 minus 1 get cancelled into f of y by x minus y into x to the power of 1 x to the power of n minus 2 plus 1 minus 2 means n minus 2. Still there will be
x to the power
n
of
minus
x
1 n
1
minus 1 into f dash of y by x plus this is y. There is no any y multiple, so take general
x
multiplication y into x to the power of n minus 1
minus
f dash
f
of
dash of
y by x.
y by x.
Okay, so see, is there any common terms? Y into x to the power of n minus 1 f dash y by x minus y into x to the power of n minus 1 f dash of y by x. These two terms get cancelled. So you'll get only n into x to the
Into
power of n
x
f
to the
of y
power
by
of
x.
n.
Okay, this is n into, but what about x to the power of n into y by f of y by x? According to from equation 1, this is z value.
X,
So this is z. So this is the Euler's theorem. X dou z by dou x plus y dou z by dou y is equal to nz. Okay, this is Euler's theorem. Yes, is it understood?
yes sir.
Yes, నేను ఎంత మీకు షేర్ చేస్తాను చూడండి. నెక్స్ట్ ఒక ఆల్మోస్ట్ ఇట్ ఇస్ 11:30. ఎస్, అర్థమైందా? ఎస్, ఇస్ ఇట్ అండర్స్టూడ్? ఓకే, సో
ఇప్పుడు మధ్యలో మాట్లాడితే వాళ్ళ ఇమేజ్, వాళ్ళ ప్రొఫైల్ పిక్ అనేది మాకు బ్లాక్ అవుతుంది. అంటే మీరు
ఓకే ఓకే, అంటే స్క్రీన్ కనపడట్లేదు కదా?
కనపడదు. అంటే
మధ్యలో మాట్లాడితే మీరు చెప్పేది వెళ్ళిపోతుంది సార్. వాళ్ళ స్క్రీన్
ఓకే 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 ఓకే, నేను కంప్లీట్ అందరిని అన్మ్యూట్ చేస్తానండి. ఓకే, మ్యూట్ చేసి చెప్తాను. ఓకే, థీరం ఇది ఏమన్నా అర్థమైందా మరి ఇప్పుడు?
మధ్యలో మాట్లాడుతున్నారు కదా సార్, మీరు డెరైవ్ చేస్తుంటే పక్కన వాళ్ళు చెప్తూ ఉన్నారు కదా.
ఓకే ఓకే, ఒకసారి చూడండి. కరెక్ట్, మీకు స్క్రీన్ డిస్ప్లే కాదు, అప్పుడు డిసపియర్ అవుతుంది. రైట్ రైట్, ఓకే, ఒక నిమిషం చూడండి, మళ్ళీ సార్ ఎక్స్ప్లెయిన్ చేస్తాను. సో నేను ఫోటో కూడా మీకు షేర్ చేస్తాను, చూసుకోండి, ఈజీగా అర్థమైతే ఏం ఇబ్బంది ఏం లేదు. సో ఫస్ట్ z ఈక్వల్ x to the power of f y by x, దీనికి పార్షియల్ డిఫరెన్షియేషన్ చేసినప్పుడు నాకు ఈక్వేషన్ వచ్చింది. సిమిలర్లీ దానికి పార్షియల్ డిఫరెన్షియేషన్ విత్ రెస్పెక్ట్ టు y చేసినప్పుడు ఇంకో ఈక్వేషన్ వచ్చింది. ఫస్ట్ ఈక్వేషన్ విత్ x మల్టిపుల్, సెకండ్ ఈక్వేషన్ విత్ y మల్టిపుల్ చేసి యాడ్ చేసినప్పుడు నాకు ఆటోమేటికల్లీ ఆల్ టర్మ్స్ క్యాన్సిల్ అయ్యి n ఇంటూ మళ్ళీ x to the power of f of y by x వస్తుంది. బట్ x to the power of f of y by x అంటే దట్ ఈస్ z, therefore it is nz వస్తుంది. దిస్ ఈస్ పార్షియల్ డెరివేటివ్. ఓకే, దీన్ని బేస్ చేసుకొని కొన్ని ప్రాబ్లమ్స్ ఉన్నాయి. ఆ ప్రాబ్లమ్స్ నేను నెక్స్ట్ క్లాస్ లో మీకు ఎక్స్ప్లెయిన్ చేస్తాను. ఆల్మోస్ట్ ఇట్ ఇస్ 12:30 అవుతుంది, రైట్? ఓకేనా? ఈ యూలర్స్ థీరం ప్రూఫ్ పర్ఫెక్ట్ చెక్ చేసుకున్నాను. దీని ఫోటో మీకు షేర్ చేస్తాను ఇప్పుడు. ఓకే, రైట్. ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? ఎనీ డౌట్స్?
ఐడియా చెక్ చేస్తారా? అడ్మిషన్ నెంబర్
సార్ వాట్సాప్ గ్రూప్ లింక్ పంపారా?
వాట్సాప్ గ్రూప్ లింక్ పెట్టినారు కదమ్మా, ఒక్కసారి ఎవరైనా షేర్ చేయండి. మీరు ఎవరైనా షేర్ చేసుకోండి, లేదా నా నెంబర్ చెప్తాను, నోట్ చేసుకోండి అమ్మా. నేను చెప్పండి సార్,
చెప్పండి సార్.
షేర్ చేసినారు చూడండి అమ్మా. చాట్ బాక్స్ లో
Sir,
షేర్ చేసినారు చూడండి. అంటే మీ నెంబర్ చెప్పండి, వాళ్ళు యాడ్ చేస్తారు. మీ నెంబర్ చెప్పండి, యాడ్ చేస్తారు వాళ్ళు.
Sir, 93.
లేదా ఒక్క నిమిషం, నా నెంబర్ చెప్తాను, మీరు నా నెంబర్ కు జస్ట్ మెసేజ్ పెట్టండి, నేను యాడ్ చేస్తా. ఓకేనా?
చెప్పండి సార్.
జస్ట్ నోట్ డౌన్ మై నెంబర్ 944 02 39 539. 94402 39539. 94402 39539.
Okay, sir.
ఓకేనా? రైట్.
Okay,
ఓకే,
sir.
స్టాప్ చేద్దాం. టాపిక్స్ అర్థమవుతున్నాయి కదా? నెక్స్ట్ క్లాస్ ఐ విల్ గోన్ టు డిస్కస్ ద ప్రాబ్లమ్స్ ఆన్ యూలర్స్ థియరం. ఓకే, యూలర్స్ థియరం ప్రాబ్లం చేద్దాం. ఈ థియరం ఇప్పుడు నేను మీకు షేర్ చేస్తాను, చెప్పినవన్నీ ఒకసారి చెక్ చేసుకోండి. ఓకే ఓకే, షల్ వి స్టాప్? ఇంకా డౌట్స్ ఉంటే చెప్పండి, స్టాప్ చేద్దామా? ఓకే, లెట్ us continue next class.
Yes, sir.
Okay, right.